So your plasmolysis, virtual plasmolysis lab. So we looked at roeo plants in hypotonic, hypertonic, and isotonic solutions, salt solutions. So this is the opening information about plasmolysis and deplasmolysis. There's deplasmolysis and plasmolysis discussed as well throughout here. And that pretty much means that when a cell is plasmolyzed, the cell membrane will shrink away from the cell wall, and it will be losing plasma, losing liquid to the outside of the cell. The liquid will leave the cell. The water, in particular, will leave the cell, leaving solute behind. In a deplasmolyzed cell, in a hypotonic solution, the cell swells. That means that the solution has a lower solute concentration, which means a higher water concentration. And so the water will rush into the cell, blowing the cells up, swelling them, and eventually rupturing them if they get too full of water. So you were supposed to observe this process in different percent solutions. You were supposed to draw pictures. So in this case, you can kind of see that the 1.1% solution is a hypotonic solution for this plant. And so the cell swelled up, right? These plasma membranes are pretty close to the cell wall, and they're kind of full. And this is a picture of full cells. Okay, and a 0.45% NaCl, which is a sodium chloride, which is the chemical formula of salt solution. This is an isotonic state. These are what the cells look like during the virtual reality experience. You saw always a cell that was in a regular state, and then the one that was given the solution. And this most resembled the regular state throughout all of the different salt solutions, because this is an isotonic state. This is a state where the 0.45% salt solution outside equals the solutes inside, and so water is moving in and out at a regular rate, at the same rate rather, which keeps the cell in a state of equilibrium or balance. Okay? And so some of these explanations are what happens and why. The cell swells in 4 minutes and 30 seconds. There is less solute and more water outside the cell, so the water moves into the cell. I could also say the water diffuses into the cell. Okay? I'm not going to read all of these, but you can read them on the screen as we go through it. So hypotonic at 0.1% salt solution. A isotonic solution would have been the 0.45% salt solution. And these you would have gotten from the virtual reality experience. It told you whether you were right or wrong on your guesses. So everyone should have put the right solution label in their lab report. 0.9%, 1.8%, 3.60% salt, and 7.20% salt solutions all were cells that were in hypertonic solutions. That means that there was more solute outside the cells than inside. And so there was more water inside the cells than outside. And so the water left the cells. Okay? The water left the cells. That means it was more water inside than outside. So the water diffused from high concentration to low concentration and left the cell. The plasma membrane shrunk away from this rigid plant cell wall, and so it kind of collects all that solute in there, which cannot pass through the cell membrane. So these are good pictures for that, and these different descriptions. I looked in your lab. I looked to see if you copied and pasted versus try to write some different things about them. And if you read these as I'm going through it, you can see that they all sound a little different. I used different vocabulary, plasmolyzed, whereas before I used movement of water. So talked about solute concentrations, hypertonic solution in one of them. So these are all different ways you can describe the same process, which is this water moving from inside the cells to outside the cells, or diffusing out of the cells when cells are in hypertonic solutions. So you then had to take a table and a graph. It says use the data table here to draw a relation between the salt concentration and time for plasmolysis to occur when cells are in a hypertonic solution. all the data you collected was not cells in a hypertonic solution. Only the salt at these concentrations were hypertonic. Remember, we scroll back very quickly. The 0.1% was a hypotonic solution, and 0.45% was an isotonic solution. So they did not give you salt concentrations that produced, the same kind of pattern of time for the condition to set in. And the condition is that the higher the concentration of salt solution, the less time it took for these cells to plasmolyze. And you can see that relationship if you look at them. As they decrease, it gets much more time. And so that graph looks like this. Okay, we're going from, at high concentrations, we had very little time, and at low concentrations, it took a lot of time to plasmolyze, and that creates this straight line effect going in this direction if I drew the other arrow point here. Okay? These are the four data points that were from the table. A lot of you give me bar graphs and really weird things, but this is what you were looking for. Okay? So it says if you encountered the Roeo plant in nature, what would you expect the solute concentration to be? You'd expect it to be the same concentration as the Roeo plant in the isotonic state, which would be a 0.45% salt solution. When was the Roeo plant in a hypotonic solution? That was the 0.1% salt solution. At what concentration did the solution first become hypertonic? Okay, at 0.9%, right? So right after 0.1%, we had that the hypotonic state. Then you had 0.45% salt solution, which was isotonic. And then after that, as it got higher, 0.9 is higher than 0.45, it started to become hypertonic, which means you now had more solute outside the cell than inside, causing a higher water concentration inside than outside, and the water leaves the cell. How did increasing the amount of solute in the hypertonic solution affect the rate? A lot of you don't understand that a rate is the time it takes. So as you increase the hypertonic solution, the rate at which the Roeo plant plasmolyzed increased. It took it took less time. It decreased, right? So we saw that, right? This is our relationship. At the highest concentrations at 7.2%, it only took about 4 minutes, 30 seconds, right around here. Versus at 0.9% salt solution, it took 14 minutes. Last one. You did the same experiment on a saltwater plant. So the Roeo plant's not a saltwater plant. Assuming that, you would expect that the plants that live in a saltwater solution would expect a higher salt solute concentration. They would have, just a higher amount of salt in their water, in the solute that they live in. That's all we were trying to get. We were trying to get you to make a connection between a plant in a lab and what a plant might be like in nature. Okay? And that's it. So, you lost points for everything that didn't look pretty much like this. Good explanations, and the explanations were a little different for some of the different, even though you had 4 hypertonic, you should have had some different things to say about them. Good pictures, correct labeling, and then some decent connections at the bottom.